Hello and welcome to Algebra 1 with Miss Betsy. We are just getting close to finishing up with Chapter 7. We've been spending the last few videos discussing how to solve word problems when we use two variables. This is our last section where we're doing word problems, and we're going to do graphing multiple inequalities on the same grid. I am going to be talking about mixture problems today. If you're using the same text that I am in Algebra 1 for Christian Schools. It's published by Bob Jones University Press. I'm using the second edition, and I am on page 309, section 7.9, mixture problems. So let's go ahead and read our first example here. This says, the nut shop sells cashews for $8.19 a pound and almonds for $6.95 a pound. The manager wants to make 80 pounds of a cashew and almond mix that sells for $7.25 a pound. How many pounds of each nut should he put in the mix? So they used to have, when I was growing up, you'd go to the mall and there'd be the store where you could buy all different types of mixed nuts, and they'd weigh them out and put them in a little bag for you. You don't see that so much anymore. But they would frequently blend their own mixes, and it would be an algebraic equation similar to this that they would use or have someone do for them, so they'd know how many pounds of each nut to mix in there so that they made the amount of money that they were looking to make. So, what are they asking us here? How many pounds of each nut? Well, you can see that I've gone ahead and set up our chart. We have cashews and we have almonds. We want to know how much of each nut we're going to put in, and then we're going to end up with an amount of the mixture, and our problem tells us that we're going to have 80 pounds of mixture. But first it's saying how many pounds of each nut. So it makes it real logical to say, let's just have X be the number of cashews, the number of pounds of cashews. Y is the number of pounds of almonds. And if you look in your problem, you see that there are 80 pounds of nut mixture that is going to result when you combine some cashews and some almonds. Now, what is the price? This right here, when I just abbreviated price question mark, we need to know the total price per pound. In our book, the price per pound for the cashews, I believe, is $8.15. Write it as a decimal, 8.15. And the price for the cashews was $6.95. They want to be able to sell this mixture for $7.25. And are there going to be more cashews or more almonds in the mix? Well, look how close the price of the mixture is to the almonds. So they're just going to throw a few of the cashews in there. Now, what is the total price? Well, the total price of the cashews that are being used in this mixture is going to be the price per pound, which is $8.15, times the number of pounds that we use. So we have 8.15x. Similarly, we have 6.95 times y for the price or the value of the almonds that's going into this mixture. So what is going to be our total price of the mix? Well, the total price of the mix is going to be $7.25 times 80. And when you do that multiplication, $7.25 times 80, you have 7 times $80 is 560. And you add another 20 for the quarter, so you get $580. It's going to be the price, or the value, if you will, of our 80 pounds of cashew almond mixture. So now we have gone ahead and we've filled in completely our chart here. Now we need to look back into the problem and say, okay, what relationships are there in here? Because I need to come up with two equations to solve. I have two variables, so I need to come up with two equations or two relationships. What do we have first? Well, we have 80 pounds of nuts. Well, The mixture is going to be cashews and almonds, so it stands to reason that you say X, or the number of pounds of cashews, plus Y, which is the number of pounds of almonds, is equal to the 80 pounds of the mixture that the manager desires to have. Our first equation right here is very straightforward, easy to pull out. The more you do these problems, the more readily you'll be able to look at the words and say, oh, I know exactly what they're talking about. Now we need to come up with a second relationship. And we can look at that just by looking at this grid. If you're buying 2 items, your total bill is going to be the price of the first item plus the price of the second item, correct? You go to Chick-fil-A and you buy a sandwich and a drink, your total bill is the price of the sandwich, $3 or whatever it is, and the drink for $1.75, so your bill is $4.75 plus tax. Well, the total price right here, or the total value of this mix, is $580, and we arrive at that $580 by taking the total price of the total value of the cashews, total value of the almonds. So you now have 8.15x plus 6.95y is equal to $580, or the price, or value if you will, of the cashews plus the value of the almonds is equal to the total value of the 80 pounds of the mixture. Now we want to look at this and say, well, what do I want to do? Do I want to add these 2 equations together? You know, what variable here can I cancel out? Well, you have weird multiplication here. Who wants to multiply by 8.15 or by 6.95? But this equation right here lends itself very nicely to just solving for y. You have that y is equal to 80 minus x when you solve this equation for y. And now you can substitute quite readily, can't you? We have a value for y that includes x. So that's exactly what we're going to do. We have 8, and I'm running out of a marker here, 8.15x plus 6.95 times 80 minus x is equal to 580. We've eliminated one variable. Now we're simply going to solve for x. And I want to glance at the book and make sure that I'm doing it the same way that they are. Before they substituted in here, they went ahead and multiplied both sides of the equation by 100, of this equation by 100. You can do that at any time. Why is it that you want to multiply both sides of the equation by 100? Because our furthest place out is the 100th place. We don't want to deal with decimal numbers. We want this to be a whole number, so we multiply by the same power of 10 as the smallest place. Hundredths, we multiply by 100. 100 times 8.15 gives us 815x times plus 695 times 80 minus x, and then we also multiply the 580 by 100, and we end up with 58,000. I could have gone ahead and multiplied, which is what I would have done, multiplied the left-hand side of the equation by 100 as well as the right-hand, but maybe for some of you this makes more sense to you. Plus, if you actually go back to your book, you can say, oh, I see exactly what they were doing. Now we're going to multiply 815x plus 695 times 80. Can you believe this? I'm going to just be lazy here. Is 55,600. 55,600 minus 695x is equal to 58,000. We're going to collect like terms 815 minus 695 at this point. Since I am hungry, I do not trust doing that in my head. So I have 120x plus 55,600 is equal to 58,000. This is taking lots of writing across here. I'm sorry my back is to you so much. We're going to subtract 55,600 from both sides of the equation and see what we have. We have 120x is equal to 22.4. I wonder if that's correct. No. $224. Okay, now this is when I write it. 58,000 minus 55,600, 0042, 2,400. What did we do? We came up with our first relationship here that the number of pounds of cashews plus the number of pounds of almonds is the total pounds of nut mixture. We now have the value or the cost of the cashews plus the cost of the almonds combination is the total cost or the total value of that nut mixture. We multiplied this second equation by 100 on both sides, keep it in balance, so that we were able to eliminate the decimal points. What we did was we converted into whole numbers here. We distributed 695 times 80 minus 695 times x, collected like terms, isolated the variable. We have 120x is equal to 2,400. You divide both sides of that equation by 120, and you have x is 20. 20 what? X is 20 pounds cashews. So how many almonds are there going to be? Y is 60 pounds of the almonds. Almonds. How did we get that for our final answer? Well, we knew that we had 80 pounds to begin with. 20 plus y is equal to 80, or y is equal to 80 minus 20, which is 60. Remember I said at the beginning there were going to be far more almonds in there. And then there are cashews because the price is closer to the price of the almonds. What you have here is by a ratio of 3 to 1. There are 3 times as many almonds as there are cashews. And that's all that you're going to do when you're working with mixture problems. I think I'm going to only do one more problem. I'm going to go ahead and do example 2. This is a postage problem. It's a gorgeous day today. It is late January in Texas. And of course our temperature, our weather here is all over the place. Today happens to be like spring. It was over 60 degrees. I had a chance to go out and ride my bicycle for 10 miles and I exercised. So there are things that are very distinctly positive about being down south. What I'm going to go ahead and do now is get this chart set up. We are finding how many pieces of mail went out. There were 2 different types of mailings that went. You had the postage was 40 cents for some, and then 64 cents for the other. And when we read our problem, you're going to see that we have some specific information that we use here. And from that, we're able to come up with 2 equations. Cost per piece and total price. When you do these mixture problems, rate problems, interest problems, you always need to set up a chart because this helps you as you're identifying how you're going to define your variables. Puts all of your pieces together where you can look at it and say, oh, okay, if I'm going to have an equation that says this plus this, like the number of pounds of cashews, number of pounds of almonds, you can look and say, oh, I'm using X for the pounds of almonds, Y for the pounds of cashews. Okay, I've got my chart ready. Let's see what our problem is. Emmanuel Christian School sent out 150 pieces of mail. Some of the letters required 40 cents postage, while others required 64 cents. If the total postage bill were $71.04, how many pieces of each type were mailed? So, we want to know how many pieces of each type. That screams XY. How many pieces of 40 cents? We're going to call X. How many pieces of 64 cents? We're going to call Y. Could I do those differently? Sure. You could have your 64 be X and your 40 be Y. There are a variety of ways that you can manipulate your equations, how you can put things together to solve many of these problems. It's whatever makes sense to you that is legitimate, then you can go ahead and solve the problems that way. This is the cost per piece of mail. How do you convert 40 cents into something you can multiply with? Well, yeah, it's a decimal number. It's 0.40, that's 40 cents, 0.40x. Similarly, 0.64y. What's their total price going to be? This is working exactly the same way as that last mixture problem did with the nuts. The cost per piece is 40 cents. Cost per piece is 64 cents. The total price is 0.40 times x, 0.64 times y. Now we have all of the pieces of information put into our chart. We're going to be able to pull together two equations. We have to have two equations because we have two variables. So let's see what we have. First sentence says the school sent out 150 pieces of mail. Well, the pieces that cost 40 cents plus the pieces that cost 64 cents would be the total number of pieces of mail that they've sent out. Next, they said the total postage bill was $71.04. $71.04, so you're going to have the part of the bill that was the 40 cents plus the part of the bill that was the 64 cents for x plus 0.64y is equal to the total postage bill. Okay? Do you recognize that two totally different seeming problems, postage, letters, nut mixture, but it's being set up exactly the same way? Are we going to want to add these two equations together with that arithmetic? No. You can see that you're going to solve for one of these variables and then substitute. What else are we going to have to do here? We're going to multiply this second equation by what? We're going to multiply by 100 because of the furthest place out is the hundredths. See what happens when we multiply both sides of this equation by 100. Rather than take up this board, I'm just going to use red in here and show you what I'm doing. Provided that red will continue to work for me. Times 100 times 100. What do you do when you multiply by 100? You move the decimal point 2 units to the right, so you have 40x plus 64y. Move the decimal point 2 units to the right, 7104. This equation right here is much easier to work with because we're not dealing with decimal multiplication. Now, I had said we can go ahead and substitute. Can we go ahead and substitute? Yes. They're saying let's not substitute. Let's go ahead and show how we can multiply this first equation by something and cancel out. What do we want to multiply by? We can multiply by maybe a negative 40. We can multiply by a negative 64. We can multiply by positive 40 and subtract. You have any number of ways that you can approach this. So let me show you what I'm going to do. We used this equation here, multiplied it to come up with 40x plus 64y is equal to 7104. I'm going to choose to go ahead, and here's where I'm going to differ from your book. Go ahead and look at your book. Make sure that you understand their thought process. Make sure you understand the thought process that I'm using here, and then use whichever makes the most sense to you. I'm going to multiply both sides of this equation by 40, by a positive 40. And when I multiply that, when I distribute the 40, I'm going to put the equation right underneath here. So I have 40x plus 40y is equal to 150 times 40. 4 times 150 is 600, times 10 is 6,000. These two equations here are the ones that I'm going to use to eliminate a variable. 40x plus 64y, 7104. 64, let me see, I'm calculating here 24 times 5. I'm checking, making sure my arithmetic is right. Yep. What am I going to do here? What happens if I add? 40x plus 40x is 80x, 104x. Doesn't do us any good. So what are we going to do? We're going to subtract the bottom equation from the top equation. 40x minus 40x is 0x. 64y minus 40y is 24y. 7104 minus 6,000 is 104. Easy arithmetic. You divide both sides of this equation by 24. Easy algebra, I guess. 24. And we see that y is equal to 4. We see that I can't do this arithmetic in my head. I really can't do the arithmetic in my head. 7104 minus 6,000 is not 104, it's 1,104. 1,104 divided by 24. You may punch this into your calculator. Let me go ahead and do it over here to our right. 1104 divided by 24. 4 4s are 16, 96. 4, 200. 144. 6 times 4 is 24, 144. We see that y is equal to 46. 46 what? 46 pieces of postage that cost 64 cents. Pieces at 64 cents. If we had a total number of pieces of postage, 46, how many pieces of postage are we going to have that cost 40 cents to mail? Well, it's 150 minus 46, which is 104 pieces of postage that had a cost of 40 cents. At 40 cents each. This is what you need to do. Remember, when you're solving these equations in two variables, you have two answers. Not only do you have two answers, you need to label those answers so we know what we're talking about. And then you should go ahead and go back and make sure that these equations work. these values work by substituting into the original equation. That's the end of our video for section 7.9. Have a great afternoon.